Hi everyone, Walter Guillioli here, and this is an overview of my midterm project for 454. My project is PumpItUp, that data mining the water table, and the image on my screen pretty much summarizes the project. We get data from Tanzania, and ideally, let me switch to my file, and I will go there. So we get data for water pumps, and basically we get roughly 40 attributes of data for each water pump, and our task is to classify the water pump. There are three potential attributes or statuses that the water pump can have. As you can see in color coded in my screen, the water pump can be functional. The water pump can be functional but needs some work, needs some repair, and the water pump is not functional. So we need to classify this, and in order to save from manual work. Imagine we get data for, you will see the counts, but thousands of pumps. Instead of just going and checking each of them manually and traveling to the remote villages, you just go from the algorithm and pick the ones that were most likely to need repair or that are non-functional. I picked this because I think it's amazing that there's a way to use data science for things like that. I want to refocus my career in the future and maybe do some of more social good type of work. And also from a learning point of view, I have done binary classification in the past, but I haven't done classification with more than two potential outcomes. So I wanted to learn how to evaluate and assess this type of models. Let me scroll this a little bit. And in terms of literature, I used the library at Northwestern. There are great resources there, and I'm just highlighting three here. There was a very interesting exercise that also has some social good, and in essence, the authors are trying to understand if there's going to be flood from a river, if there's going to be natural catastrophes like floods. And interestingly, they use random forests, which, as we will see at the end, is my main the algorithm that gives me the best results. In terms of, let's jump into the project. There were basically three data sets that were provided to me. The train data is provided in two files. One basically has the values and the other one has the labels. So it's a very easy merge or a join in SQL to join this. And we get almost 60,000 observations. Then for the test data, we get almost 15,000 observations. So what I did is combine these two to get roughly 74,000 observations, and I do all my data exploration and preparation for that. In total, I get 41 variables, and I'm going to talk about those next. The first thing I do in terms of data preparation is address missing values. Fortunately, out of the 40 attributes that I'm getting, only 7 had missing values. Interestingly enough, all of them were categorical or string or character attributes, none of them numerical. So in the table one at the top of my page, I'm basically just including the number of missing values per each of them. So I did something very easy. I just imputed a missing value attribute in them just to see if that in itself would be a potential predictor. And I check that later when I do my EDA. If I would have gotten numerical variables, I'll usually do the median just to keep it simple. Then if we go to the next part, which is just checking the variable that I'm trying to predict, that is called status groups, you can see there just the counts that I have, both for the train and the test set, and just a proportion for those in the train set. As we can see, more than half are functional, only 7% need repair, and 38%, which is a huge number, are non-functional. In terms of, I'm going to summarize this part relatively quickly, but in terms of, I split the data exploration and preparation. I do it first for the categorical variables, and then I do it for the numerical variables. So for example, let's take, for example, date recorded. That's just a string data for me, even though it's a date. So there are a couple of things I did there in order to leverage data from this attribute. I simply computed, I derived two metrics. One is how many days lapsed since the recording of the status of the pump has passed. And I picked end of December of 2013 just because that's the month that this data set ends. And I also created a month recorded. Lubridate package has really good functions for this, just to see what month and to see if there's any seasonality. For example, all the pumps that are checked in December fail, for example. I'm making that up. I'm not gonna go through all of them because I have over 30 of this, but I just want to highlight probably the interesting things that I saw. For example, name of the water point, WPT name. There's thousands of distinct values for this one, so I just decided to drop it. I didn't see any feature creation I could do, so I just drop it. Sometimes it's hard to drop data, but we need to learn how to do it. Basin, for example, which is just the geographic location, that one has 9 potential values, so I decided to keep it and that transform it as a factor. Then I found some redundant values. For example, take region and region code. I did aggregations of both, and both offered the same type of information, just at a slightly different level of granularity. Like region has 21 values and region code has 27. So I just had to make a call at this point. And in this case, I decided to drop, opted for simplicity, and I decided to drop the one with 27 values. When I looked at the bottom ones, district code, LGA, and ward, they are repetitive. They are just more information on region, and you can see that by doing aggregations. So I just decided to drop those. Construction year was an interesting one, which in essence, you have 55 different values. So that one offers very interesting information, and I had to apply some subjectivity to it. There's a lot of them that have 0 that could be a missing value, it could be an error. I just left it at 0. And then you have years from 1960 to 2013. So in essence, what I did is I recoded this variable, and I basically kept the top 10, and then I added an 11th factor that it's the rest of the years. I'm just trying to keep my categories to a manageable size. I do this, I guess, by gut. In a way, I don't have a very specific number to do it. I'm gonna probably skip this because the points are very repetitive. Yeah, and then let me jump to the data exploration preparation for numerical variables. There's a couple of this, and for example, this one is just the amount TSH is the amount of water available at the water point. And you see a very big range from 0 to 350,000 on this one. You have a long tail, so I trimmed this at 95 percentile, very subjective. I usually do 95 or 97, and there's a lot of zeros. So I kind of created a flag call to see if the value of 0 is a predictor or not. I guess I didn't even need that because the 0 will be there in the value, but I decided to do it anyway. Number private, for example, the description is not provided by the data set. The range is very broad. There's a long tail. I didn't know what this was, so I just decided to drop this variable. And then you get GPS coordinates, and you see the ranges there. I decided, and the distribution is relatively normal, so I decided to keep it. Then let me jump in super quickly how I do exploration of the variables as potential predictors. In the case of the categorical variables, I just looked at the distribution and proportions, and I'm going to show you a chart at the bottom by each of the status of the water pumps. And in the case of the numerical variables, I do box plots to see the distribution. So this chart summarizes both approaches. In the left, I use the mosaic plot, which I like, and I can see, for example, for public meeting, if there's a difference in the proportions of the water pump status, depending on the value of public meeting. There's nothing very interesting here in that case, for example, and then to the right, I just show you how I do it for numerical variable. In this case, I show GPS height. You can see some differences in the median, in the mean, but not so much in the distribution. So it's not a very, very exciting example. I have all the results in the appendix for this as well. In terms of modeling, I tried 3 different techniques, but I mostly did random forests. I just got excited with it, and I played with different factors. You can see the summary there. In the first one, I tried just the defaults that the algorithm offers. In the second one, I just tried to force the algorithm and tune the parameter and say, hey, try all the variables at every split. This took forever, and it didn't give me didn't give me improvement at all, interestingly. And the third one, I just tried to say, okay, let's just build, uh, instead of 500 trees, let's do 50. Then I did logistic regression, and I picked the variables based on the EDA and based on my exploration of the data. And then I tried support vector machines as well. As you can see, so what I did is I basically split the train set on a train set and a validation set that I used to get some accuracy measures, and then I picked and then I submitted this as drivendata.org, and I have all the scores there. Once I have my winner, which is the first one, I use all the data to rebuild the model and then submit it to drivendata.org. I'm super pleased to say that my accuracy was 0.8228, and that's really that put me in position 143 out of 4,258 competitors. So pretty good. And more important than that is not even close to half percent is the improvement that position number one has over me. So if I did my math correctly, we're talking about the test set has 15,000 water pumps, and that's just 75 pumps. I mean, it's still significant, but it's not that much. And with that, I'm gonna conclude my presentation. I hope this was helpful to all of you. Thank you very much.